Hi everyone, this is Ruth and welcome back to my channel. This channel is mainly about my home lab where I build different setups, test networking tools, and experiment with infrastructure projects. My main goal with this lab is to practice cybersecurity skills in a real environment. So over time, I'll be building out different systems, security tools, and monitoring platforms. In this project, I built a centralized Windows security monitoring lab using Splunk Enterprise, Sysmon, and Splunk Universal Forwarder. The objective was to collect Windows event logs and Sysmon telemetry from a Windows server and centralize them within Splunk for security monitoring and analysis. This project demonstrates practical SOC analyst skills, including SIEM deployment, endpoint monitoring, log ingestion, and event investigation. This lab was deployed within my Proxmox environment. The environment consists of Ubuntu desktop running Splunk Enterprise, Windows Server 2025, Sysmon for endpoint telemetry, Splunk Universal Forwarder for log forwarding. Windows logs are forwarded to Splunk over TCP port 9997 and stored within a dedicated index called Win Event Log. The goals of this project were deploy Splunk Enterprise, configure Splunk receiving ports, install and configure Sysmon, deploy Splunk Universal Forwarder, collect Windows event logs, collect Sysmon telemetry, validate event ingestion, and investigate endpoint activity through Splunk. The first step was deploying an Ubuntu desktop virtual machine within Proxmox. Ubuntu was chosen because Splunk Enterprise supports Linux deployments, and Ubuntu is widely used in both enterprise and lab environments. I allocated sufficient resources to ensure Splunk would process and index logs without performance issues. Before installing any software, I updated the operating system. Keeping systems updated is important because it ensures security patches and package updates are installed before deploying production services. Next, I downloaded Splunk Enterprise from the official Splunk website. Splunk was selected because it is one of the most widely used SIEM platforms and is commonly used within security operations centers. The package was downloaded as a compressed archive, so I extracted the contents. I then moved the installation directory to OPT, which is a standard Linux location for third-party applications. During the first startup, Splunk requires the license agreement to be accepted and an administrator account to be created. This account is later used to access the web management interface. Before proceeding, I verified that the Splunk service was running successfully. Confirming service health early helps identify issues before additional components are introduced. Splunk provides a web interface that allows administrators to manage data ingestion, create indexes, perform searches, and build dashboards. Successfully accessing the web interface confirmed that the installation was functioning correctly. At this point, Splunk was running but was not yet accepting logs from external systems. The receiving port was created so endpoint systems could establish a connection and send event data into the SIEM platform. Port 997 is the default port used by Splunk Universal Forwarders. I verified that Splunk was listening on the configured port. This helps ensure that endpoint systems will be able to connect successfully later in the deployment. With Splunk ready to receive logs, I moved to the Windows endpoint. The next component installed was Sysmon. Sysmon extends native Windows logging by providing detailed visibility into endpoint activity. Examples include process creation, network activity, driver loading, registry modifications. These events are extremely valuable during investigations because they provide much more context than standard Windows logs. To verify Sysmon was working correctly, I generated endpoint activity by launching Notepad. New Sysmon events appeared immediately, confirming that endpoint telemetry was being generated successfully. Although Sysmon was generating logs, those logs still existed only on the Windows server. To centralize them, I installed Splunk Universal Forwarder. The Universal Forwarder is responsible for securely collecting and forwarding logs to Splunk. By default, the forwarder does not automatically collect every log source. The input's configuration specifies exactly which logs should be collected and forwarded. For this lab, I choose security, system, application, and Sysmon operational logs because they are among the most valuable sources during security investigations. Creating a dedicated index helps organize data and makes searches more efficient. It also reflects how many organizations separate data sources into different indexes for easier management. Once the forwarder was restarted, logs immediately began arriving within Splunk. This confirmed that Sysmon was generating telemetry. The Universal Forwarder was collecting logs, Splunk was receiving events, the data was being indexed correctly. At this stage, the logging pipeline was fully operational. Sysmon was generating endpoint telemetry, the Universal Forwarder was collecting the logs, and Splunk was successfully receiving and indexing the data. However, simply collecting logs is not the final objective. In Real Security Operations Center, analysts use this telemetry to investigate activity occurring on endpoints and identify potential suspicious behavior. To validate that the environment was working as intended, I generated several activities on the Windows server and then investigated the resulting events within Splunk. To generate telemetry, I launched several common applications on the Windows server. First, I launched Notepad. Next, I opened the command prompt. Finally, I launched PowerShell. Each of these actions creates a new process on the endpoint. Because Sysmon is installed and monitoring process creation activity, it should generate event ID1 entries for each process. Once the activity was generated, I moved back to Splunk to determine whether the events had been successfully collected. One of the advantages of centralized logging is that analysts do not need to log directly into individual systems to investigate activity. Instead, they can search and analyze events from a single platform. This search returns Sysmon process creation events. Event ID1 is one of the most useful Sysmon event types because it records when a new process is executed on the endpoint. Process creation events are commonly used during incident investigations because many malicious activities begin with a process being launched. As shown here, Splunk successfully captured the process that were launched on the Windows server. This confirms that endpoint telemetry is being generated, forwarded, indexed, and made available for investigation. To perform an additional validation test, I generated another event using the NSLookup utility. Although my current Sysmon configuration does not generate the NSQuery event ID 22 events, I can still verify that the process execution itself is recorded. Here we can see the execution of the NSLookup process being recorded by Sysmon and has successfully forwarded into Splunk. This demonstrates how endpoint activity can be centrally monitored and investigated using the same platform. One of the most valuable aspects of the project was troubleshooting. During deployment, I encountered an issue where logs were not appearing in Splunk, even though the Universal Forwarder appeared to be configured correctly. After investigation, I discovered that the target index had not yet been created because the win event log index did not exist. Splunk was dropping incoming events. Once the index was created, event ingestion immediately began working correctly. I also encountered a situation where the Universal Forwarder reported the receiver as inactive even though logs were successfully arriving in Splunk. This reinforced an important lesson. Actual event ingestion is often a more reliable indicator than service status messages alone. Overall, this project successfully demonstrated how endpoint telemetry can be generated, collected, centralized, and analyzed using Splunk Enterprise and Sysmon. The environment provides visibility into Windows endpoint activity and establishes a strong foundation for future projects involving threat hunting, detection engineering, and incident investigation. Thank you for watching this walkthrough of my Sysmon and Splunk monitoring lab. I look forward to expanding the environment further and sharing future cybersecurity home lab projects.